Hello and welcome to the channel. Let's take a look into structured concurrency, which is a preview feature available in JDK21. So if you're not familiar, it's some work that Java is trying to do to improve how you write concurrent applications. And in Java 21, the virtual threads are already enabled by default. So I have some videos on the channel about that. In nutshell, virtual threads are lightweight threads, and you can follow the pattern of creating a thread per task. And in that case, if your virtual thread is blocked on some kind of input-output, it will be automatically detected, and this thread will be removed from the carrier thread, which is like a old-style platform threads in Java, which are heavy, and a new virtual thread will be placed inside and it will execute. So in that case, you don't have to follow the reactive programming patterns, etc. It's all done by JVM itself for you. But really, it's not enough. So it simplifies a lot. It allows much more concurrent programs. But what about the scope and how we control multiple threads? So let's take a look into this example. We have two methods, get A and get B, and inside it could be anything like an HTTP call over the network or a query to the database or some long-running job. And in your application, you basically want to get A, get B, and then combine results, right? In non-concurrent approach, you can just do this, like let A get A, B get B, and then do concatenation of the results. But what if these calls are slow, and what if you want to parallelize that and do that in the same time? So in this case, this code will be something like rabbit in the future, right? Or execute those two functions on a thread pool. But now we have problem, and for example, get A is throwing an exception, right? And we will know about that when we do the deref of A here, right? But B will still be completed, and we'll kind of waste time. But what in opposite case, if A is fine, but A is like a long-running job, if we do get B, now B failed, but A still took a long time to complete. So we kind of know about the failure here after we already waited for a long time for A to complete. So from this example, we can convert this simple code into something more complex, right? You can check the status of get A, you can check the status of get B, and if something is failing, you can terminate the other thread, etc. And from a simple code that's easy to read and maintain, we can eventually create some Frankenstein that is really hard to maintain. And it's just two function calls, right? Imagine if you have more than that, more calls, or even worse, when inside get A, it's also a couple parallel threads, right? So we now have this tree of threads, and we want some kind of control to make sure that first we fail fast if we want that. So if there is an exception in one of the threads, we want to terminate the entire block or entire scope, and we want to get the root cause exception available for us, or we want to wait until everything is completed, and then we make sure that nothing failed, and we can get a result of every thread. So in this case, let's see what is the proposal from JDK21. It's called Project Loom Structured Concurrency. And by default, it has two policies built in. One is shutdown on failure, and the other one shutdown on success. If you want to run this example, you need JDK21, and also I'm using line again in project CLJ file. you want to enable the preview. So this is -- enable preview JVM flag. All right, let's start with creating a new function. So let's say shutdown on failure demo. And everything is built inside this new thing called scope. And you can wrap it with open. So basically you do this try with resource that will be closed eventually. And when this scope is closed, all our threads that we will spin inside the scope will be closed as well. So yeah, we do with open, and then we say scope here, and we want shutdown on failure. Let's go here. Now we need to spin 2 tasks, and the API for that is this. You call fork on the scope and pass a function that you want to execute. In this case, this get A and get B here will be executed in different lightweight virtual threads. All right, so at the end, we want to join them, so it will be join on scope. And we will throw if failed, right? So this throw if failed is actually kind of like a guard from this code to the other things that we write below that. And it basically means if we have a failure in one of our tasks, we'll terminate everything. We will get original exception here. So after that, we want to get our data from our subtasks. And let's actually wrap that into a let. So A will be this, and B will be this. And let's move this inside. So now let's actually call this function inside our main. So let's call it shutdown on failure demo and lane run. So now we have returning A, returning B. I also want to print ln the result. Let's run it once again. And as you can see, we have A, B, right? But what if we put a runtime exception right here? So get A will return a failure, right? And now we can, as you can see, we have a proper exception, and it's actually because we have this throw if failed. But the other thing is that if we make get B a long-running task, we will probably won't even see this returning B, as you can see here, because our exception from A will trigger the shutdown on failure policy, and the other task that we created, the B one, that's like a long-running one, will be terminated. So we don't waste any time here waiting for some other task to complete. So that's the first policy. The second one is shutdown on success. So here we'll have shutdown on success. And in this case, I believe we don't even need our let, because there'll be a result method that will combine the results. And shutdown on success is opposite of the failure. The first task that will complete it will be picked as the result of the entire scope, right? So the use case for that is that, for example, you query the same data from 3 sources, and you're happy with whatever result you get. Like, you get result from the first one, you're fine. If first one is slow, you get the results from the second call. It's also fine. You want to return that. So it's like you can call it as alternative between different ways, different sources. So in this case, we want again to join on our scope, but on top of that we call result, and this result will be either get A or get B. So now let's go here, let's call it shutdown on success, and let's randomize. So let's remove the throw from here, and let's randomize the sleep time. So sometimes this will be faster than B, sometimes the opposite. And let's execute our demo. So now we have returning B, right? Let's run it again. Maybe we'll get lucky and we'll get A. B again. Returning B, but let's now make sure that get A is really quick. Let's like 10 milliseconds. Let's run that and probably will now get A. Yeah. And also if we'll get, for example, exception from A, it doesn't really matter in this case. If we get B will be finished first, we'll still get B, and the rest of the threads is actually terminated, so we don't see exceptions, we don't see this returning A if B is successful. So again, this optimization here, we finish as fast as possible. Once we get one successful result, we execute our scope and return it. And also, this scope could be passed inside. So as I said, you can create this tree structure of threads, and proper exception will be propagated from any thread inside, and then every thread will be terminated quickly if we need to exit the scope. Cool, I guess that's it I wanted to show today. I'm really looking forward to trying that more, hopefully in production code at some point. But this looks all very promising. Let me know what you think in comments, and see you next video. Bye bye.